Welcome back. Let's finally get into object-oriented programming. And our goal throughout the next couple of videos is to show you an example of how we can go from procedural code, from code that we repeat ourselves in, that isn't really well organized, to code that goes all the way to object-oriented programming. We'll start from the very basics and each time improve little by little until we get to the end. Now, we need a good example for this. So what should we do? I have an idea. How about we create a game, or start to create a game where, let's say it's a fairy tale game with all these characters that interact, play with each other. Maybe they fight one another or communicate with one another. So using this, let's create a program that has object-oriented principles in mind to organize our code. How should we start? Well, we definitely have else over here in this game, so I think the best place for us to start is to create, well, else. Let's go ahead and do that. The very first naive approach is to, well, create an elf object, right? And our alpha object, we'll keep everything basic for now. We'll definitely have a name for our elf. Let's create an elf called Orwell. And this elf will have a weapon that, what do elves usually have? Let's go with bow as the weapon. And then we can attack with this weapon using, well, just return attack with, and then we can just do elf dot weapon. So that now if I do elf dot name and I run this, I get Orwell. If I do elf dot attack and I run this, attack with bow. Awesome. There's our elf. But in this game, we're not going to have just one elf, right? We're going to have multiple elves with different names, different weapons, maybe even different methods. So what should we do if we want to add another elf? Well, we copy and paste this code and create elf2. Maybe the name is Sally, weapon is bow. And once again, if I want to create Sally, I do elf2 attack. And there you go. We have Sally attacking with a bow as well. Now, what's the benefit to what we've just done? And at least moved us towards object-oriented programming. Well, we have something called encapsulation here. We've grouped functionality together. We have state, that is data within the object, and functions or methods acting on that state. So these methods can, well, interact with the state, such as read it. They could even modify it. We can have a method called change weapon that changes weapon from, let's say, bow to sword. That's our first step in object-oriented programming, is we've encapsulated functionality that can be contained to model real world, such as else, into these containers. That's good. But what's the problem with this? Well, the clear problem is that when we need more elves, which in this game we're going to have a ton of elves, we have to copy and paste the same code over and over. Even though all the elves have this same attack method, we have to copy and paste, copy and paste, copy and paste. And most likely, we have way more code than this that elves can do. Way more properties, way more methods. And we're not keeping our code very dry, right? We're just constantly repeating ourselves. So let's move on to the next level. That is to step 2 of object-oriented programming. Let's go with factory functions. And factory functions, as the name suggests, are functions that act like factories. They create objects for us. So let's do that. I'm going to create a function create elf. So let's programmatically create elf. And this create elf is going to have name and weapon. And we're just going to return a new elf every time we run this function. So I'm just going to return an object, and inside this object we have name, we have weapon, and we have attack. And once again, the attack is going to return for us attack with the weapon that we have. So now here, if let's say I do const Peter and I create elf, and this elf's name is, well, Peter, and the weapon will be, let's say, stones, a very primitive weapon. If I click run, and, well, let's run peter.attack. If I click run, I get attack with stones. All right, so that worked. We've created a factory function. That is a function that creates objects for us. And we can even simplify this a little bit using ES6 syntax, where if property and value are the same, we can just keep it like this inside of an object, so that this still runs. And the beauty with factory functions is that now if I want to create another elf, all I do is create, let's say, Sam. And Sam's weapon is fire. If I do Sam attack, I have attack with fire from Sam. And instead of me copy and pasting code, I now have this function that just creates elves for us. We've moved up the step towards object-oriented programming. We avoided repetitive code. But there's still a problem here. Factory functions are great, but can you notice something that we can improve here? What if we had 1,000 elves? And those 1,000 elves, they require space in our memory, right? To store the same data. And things like name and weapon, well, they're going to be different. So we need to store that data in memory for each elf. But methods such as attack that are pretty generic and they're the same thing, that is going to be copied onto memory in a different location for each one of these elves. So if we had 1,000 elves, that's 1,000 attack functions in different places in memory for each elf. That's not the best, is it? Luckily for us, JavaScript has this interesting thing, right? We learned about it in the last section when we talked about prototypal inheritance. We can use that to our advantage to maybe improve this so that we share functionality across different objects. Let's get to that in the next video.